All right, hey everyone, I'm David Room. I've been a little bit sick for the past 2 days, but I'm feeling better now, so we're going to get back into working on my retro space combat game project. I'm doing something really exciting, which is adding gravitational forces and some orbital mechanics into the game. So, a lot of the work that been doing in the last few streams has been kind of refactoring certain parts of the simulation and physics stuff uh, towards this, anticipating this, where we're starting to have some forces from gravity, some forces other than, ship thrusters and things in play. And there's a few different reasons that I wanted to get into uh, actually adding gravitational forces and orbital mechanics. This isn't going to be a hard sci-fi game exactly, but I wanted to make things a little bit more realistic, and we'll get into that uh, in a sec. But for now, let me let me just get some music going, and we'll get into it. I think I've shared on X that uh, we're doing a stream tonight, so people there can join if anybody's up. And we're gonna keep listening. I really love this plasma dark synth mix from Whitebat Audio, so we're gonna listen to that some more. Yeah, so let me just show you guys what I've been working on. So, yeah, like I said, we were kind of refactoring some different forces and things like that. And I added a new type of object that can be in the game. So, there are a few different kinds of things in the game, and the main three. Well, before this, oh, shucks, I gotta sign into the chat here. So. The main two things that we had before were entities and projectiles. So entities are basically the ships, right? So this is a space combat game, so that they're ships. Projectiles are kind of similar to entities in that they're objects that move in space. They have collisions and different things, but they just have much simpler physics behavior. I don't really care about the orientation of projectiles. Basically, they are going to go in a certain direction, and I guess they do have an orientation, but it doesn't change. They don't really have any they don't have acceleration. I guess that's kind of the difference with projectiles. They don't have acceleration or angular acceleration. So they basically just go in a straight line in a certain direction until they hit something, and then they're done. So the new type now we have is celestial bodies. So this isn't necessarily final, this is an ongoing project, and that's the fun part here. Everything can be refactored. But celestial bodies basically have a name, a mass, and they have some physics state type stuff. Kind of like entities. They have a position, rotation, velocity, but like projectiles, I'm not really modeling accelerations. I think for now I'll mainly be modeling like one major celestial body that the ships are interacting with. We can always add more once we get further into this, if we want to simulate like being able to go between a planet and moon and stuff. Some of the work that I did that kind of enabled this is like making a lot of the coordinates double precision. So we have that precision in where things are. We can understand the positions of things over a much greater scale. So now, instead of having the sort of origin or reference point, that doesn't have to be sort of in the play area. It could be, the center of a planet, or we can talk about distances from things to things that are that far away. So in addition to this, the other thing that I did is I added something kind of important, which is the ability to have a different reference point for the play area. So in the past, we kind of considered 0, to be, the origin point to be an origin, and there's some things that we do where we sort of recenter that coordinate system around where the player is. But now we have the capability to say, let's consider a specific entity to be the origin for the purposes of the flight assist system. And what that allows us to do is it allows us to be modeling ships and space stations and things in orbit, understand their sort of global velocity, but be dealing with trying to navigate and fly around them kind of in that local coordinate system that they're in. So to show you what this looks like. So I added this space station to mission 4, and let's see, where is it? And basically I put this space station kind of a ways away from where the player is. So it starts at 0, 0, 0. And then I do some setup here. So we're going to use the real radius of Uranus and put Uranus sort of over on the left-hand side with 1/4 of its radius of altitude of orbit. And then we set up some velocities that put us in circular orbits given the gravity that Uranus is going to exert on our ships. And we do this, I believe, just for the player ship and the space station. So there's some other ships in this scenario, and they're just gonna fall. They're basically just gonna fall out of the sky. So we don't have to worry about them. But there's a couple interesting things that go on here that I just want to show what this looks. So if we launch this, so when I launch this, I'm not going to be setting that origin for the flight assist system yet. We'll just keep the current system, which is 0, 0, 0 as the origin. And you can see our velocity is very, very high here. We've kind of, I'm capping it for the purpose of the gauge, but our velocity is very high. So that's kind of like the orbital velocity that we have to be in to be orbiting Uranus. And you can see that we're sort of roughly staying in the same general distance to this station. And if you look at the forces on us here, you can see that we've got a force of gravity from Uranus, and then we have these little tiny kind of intermittent forces from our drive and thruster systems that are sort of just kind of correcting for some drift. Now, if I there's a couple interesting things I can do here. So if I just drift, so I'm pressing the D key here, you can see that that sort of disables the drive and thruster systems. Not much is really changing here. Now I do have this target velocity here. Oh, and I think actually that's what the drive thrust is doing, is it was trying to adjust my target velocity to that. Yeah, that's what was going on. So yeah, like you can see here, yeah, it's like yeah. Now, if I do something here, so if I set my target velocity to 0, let's see here. Oh, okay. Yeah, let's see here. Oh, okay. I see what's going on. I'd already set the reference entity to that. That's what was going on. Okay, so yeah, here's what we want to do. So if I turn this off and drift, we're gonna see that, yeah, we're staying roughly in the same spot because we're both orbiting. Now if I stop drifting, it's gonna try to kill off my velocity, right? So now I'm accelerating against that velocity, and our you know, it starts moving away. You can start seeing the shape, like the direction that it's going. And if I start, if I do the same thing, and if I start without any velocity, you can see this was kind of another nice gut check. So you can see the station moving away because it has the orbital velocity, and then you can see that because of the force on the planet, my thrusters are exerting a force to try to keep me from accelerating in that direction because of the flight control system. So this was kind of something that I was curious about. Like, if you just wanted to say, okay, we're in orbit, but we have sort of a static reference point, depending on how far away from the planet you are, you can just kind of play the game as normal, and it doesn't really matter too much because our ships are capable of producing some like very high forces and accelerations, but at least we're able to model that accurately, right? So a few different gut checks there to see that things are working correctly. Now, if we now, this is kind of the behavior that I'm pretty excited about. So let's give ourselves the initial position, and then let's keep the reference point for the flight control system. So now So those other ships get left behind, right? I'm in orbit, but uh, this 155 meters per second, right, is relative to the position of that station which is orbiting. So I'm closing in on the station. And we'll accelerate up a little higher, and I will do the time multiplier. So we can, we'll come a little closer here. And so now we can approach the station. And this velocity indicator, you can see that's showing the sort of orbital velocity. That's still in the global coordinate system. But we can fly around the station now, and this pretty much plays just like the game played before, where we weren't in orbit, right? But you can actually see the shadow map on the station kind of flickering, because it is moving. And what I want to do today is I had an idea for something really cool to try, which is to do sort of a 3D visualization in the HUD that shows your orbit relative to, you know, orbits of your allies and enemies and things like that. And we should be able to see, if we can build this visualization, we should be able to see some of those effects like I just showed, where we stop, you know, like accelerate in different directions. You know, like if I unset this guy right now, let's see here, if I go up here. So what I'll do is I will, let's see here. Like if I drift now, right, nothing happens because I'm still sort of in the same orbit as the space station, right? But if I say, okay, remove that space station as the reference point, and then say my target velocity should be 0, I'm gonna kind of, I'll see it move away, right? So if I set none as the reference point, right? And then especially if I see, so now my velocity is dropping, so I'm slowing, and the station is moving away. And if we had a nice visualization, what we would be seeing now is we would be seeing the station's orbit stay the same shape, but as time went on, we would see my orbit changing, right? That's in a way that's going to take me on a trajectory into the planet. And I think so like I have a couple things where I'm showing some orbital parameters. You can see my eccentricity is increasing, so and I want to add a radius and altitude to this too. You can see that start changing, and we'll get a better feel for the actual like orbital mechanics of what's going on here. So that's where we're at. Yeah, so Doug Wise has a couple of comments in the chat. He says, how long is the station again? I think that station is a kilometer long, or a half a kilometer. I forget the exact amount. And yeah, and Doug says the orbital drift looks great, subtle but adds a lot. Yeah, it's a neat effect, and you know that's one of the cool things about stuff like this is like, you know, a lot of the orbital mechanics stuff that we're going to be looking at is like doing some equations that sort of are a particular way of describing the geometry of what's going on. But you don't really need that geometry to have this happen, right? You can just sort of put things there, and you can put the forces on things, and it happens. And that's what's kind of fun and exciting about this, is like you get this beautiful stuff that starts happening, and there's some aspects of it that don't, maybe are intuitive, maybe aren't, but it's pretty cool. So yeah, so let's get into this. Let's first of all, let's just add that radius and altitude to the little orbit MFD, and we can double check that works. So let's just see here. So here's what I'm talking about. We've got this orbit's here. Our eccentricity is super low here, and then if we set that to 0, then immediately it starts climbing, especially if we drift. And I think like what we would see too is like if I start accelerating in the opposite direction, we would see that increase faster. Yeah. And our forces and our accelerations are very high compared to what the planet is exerting on us. So we should be able to see these things change very rapidly once we start doing the visualization, I think. So yeah, let's add that stuff to the HUD MFD screen, and then we'll do some cool 3D visualizations. I think we can pull the pieces together pretty quick. Okay, so let's just close a bunch of this. We're not going to be messing with the mission too much here. I've got water, coffee, and some Mountain Dew, so I'm ready to work on this for a good while. I think it's update. Orbits MFD. Okay, so we're gonna add a couple rows here. So we're gonna do a radius. Now this isn't an orbital thing. This is just gonna be our vec length. I don't know why I did not think to look for stubs for Panda. It's so much nicer working with these things, having those stubs. Getting the autocomplete on all these different types. So okay, and then I don't know if there's like a correct term for this, but for now we'll call it A. That's just going to be rvec.length minus the body's oh nice, we don't have an actual radius of the body, so that's something that we got to add. So let's add that in. That's funny, because I did use that in the mission. Uranus. Okay, so that just needs to be... Okay, so that's a nice quick change. This would be meters. Another thing that I want to do either tonight or very soon is I need to get a little smarter with how I'm showing distances. Sorry, I'm still a little sick here. Right now I'm just showing meters for everything, and I need to do some logic where I start showing kilometers and maybe even scientific notation for big distances. Because now we're getting into, there's, you know, a lot of things where distances can be pretty far. Okay, so let's just make sure that these things work like we expect, and then we will start working on that 3D visualization. That'll be fun. Okay, so let's see. Did I... and see. Yeah, see, these numbers are just really big. Yeah, now and see that those two numbers shouldn't really be changing. I think it's mainly because I oh yeah, they're changing because I am changing my orbit because I'm moving towards that station a little bit. Oh yeah, and I'm not on a perfectly circular orbit at this point, right? Because my eccentricity is not exactly 0. So that's what's going on. Now see, actually, let me just add units to these. That doesn't actually look horrible. I definitely don't need 3. Can I do .0f? Because I don't. If I'm using meters, I don't really need. Yeah. See, it's just silly stuff like this. Like, why do I have fractions of a meter on my distance stuff, right? Like, I just don't. That doesn't need to be a thing. Let's just fix that quick. Just see, it makes sense for things like velocity and acceleration, but it doesn't really make sense for distance. Let's see here. Where am I setting? It's going to be one of these that's got like 1F. distance, there it is. Distance text is just going to be that. I bet that'll get both spots. Let's see. Yeah. Yeah, okay, cool. And see, I probably need to replace that with kilometers, like something like a single decimal point kilometer would probably be a lot more useful here. So, you know, 24.7, 24.8 kilometers. Although having this precision for what we're doing now for the orbits stuff is nice. Okay, so yeah, let's try to add a 3D visualization of some kind here. So what I'm picturing is I want to have a sort of ball that represents the planet, and then I want to draw the full rotation of what the current orbit is like. And if we can, it might be nice to do some lines for some of the different orbital parameters, like the ascending node and like periapsis and stuff like that. But I'm guessing that we won't get that far tonight. I don't want to spend a bunch of time Googling stuff on stream necessarily, but we'll see. So let's get started here. So we have the idea in our HUD of different elements that are 2D and 3D. Let's just actually start by making a new module. Oh, and I'll actually show you here quick what this will kind of look like. So I was working on something last year. Let's see, can I launch the hanger like this? Yeah. So in the simulator, just to test this out, so I'm picturing a planet that looks like this, and then probably won't be an animation, but it'll just be a fixed sort of wireframe orbital ellipse is what I'm picturing. There might be a couple little shader things that we've got to do for this or refigure out, but we'll figure that out. This is something that I'm excited to, like getting this functionality in here and like being able to test it in this simulator, where we could do different missions on different planets with different gravity and maybe even like different orbital distances. The other thing that we've got to do at some point too is handle the actual background planets. So right now they're just things in the skybox and they don't really move according to where you are, because I wasn't really thinking about that before, but now we're going to have to start dealing with you know, scaling or doing different things with those background planets, because we're actually potentially going to be covering big distances now, which is exciting. So yeah, okay, let's get into this here. I'm gonna bring up this orbit stuff, and we'll actually make another file here called orbits for oh nice. Okay, so Spaghetti Software here in the chat. Sorry, my bar keeps popping over to the bottom here. He has a great comment. He says, I'm working on a space game as well, starting to hit those upper thresholds of distances and smoke and mirrors to make things work. Yeah, so one of the big things that I had to deal with almost right away was implementing a floating origin coordinate system. So that knocks out a lot of like weird stuff that you start dealing with, and is kind of necessary. And then I'm excited because um, I just implemented sort of tracking the positions of things with double precision. So that will give us like very large scales that work nice in terms of the like real locations and distances and things that we can measure. There's still this process where things are moved into like single precision coordinates for rendering, but you know, everything that we want to render should fit in that nice a smaller area, and then we can do that sort of smoke and mirrors trickery for stuff like the planets in the backgrounds and stuff like that. So okay, so I've been kind of trying to do this new style of where I'm kind of doing more stuff with these sort of record types. And let's see here. So this will be a Orbits UI. Most of the UI components have a font that we pass in, and it feels good to be writing some actual code. My work now, it's just like use agents all day long, and it's man, I like writing code. It's fun. It feels good. Agents are nice and efficient, but it's fun to have projects when you care about the code you're writing, where you're actually writing code. Okay, so let's follow some patterns here. So let's see here. Let's 3D. We're just setting up some node paths to hold different things here. Yeah, so Spaghetti Software says agents are good at helping you read other people's code. Lol. Like, please help me understand this. Yeah, that's something that I really like them for. It's, I think a really good way to understand what AI is it's just like hyper-powered search, right? So, so if you need to search things and kind of like ask very complicated questions about things. I've used them recently for sort of like figuring out like I work in machine learning and computer vision and things like that, and I do a lot of work where I have like different scripts that I use to set up different experiments, and I kind of try to leave a trail of that. And I found agents are really good for, like, you can say, okay, now where did this data come from, or what was I doing when, and it can, because it can sort of hold all that in its context, it can piece together what happened, and it's very good. Like, if you can get the right things into the context, you know, I think for a long time I kind of thought, oh yeah, it's like you kind of can't trust anything they say, but it's like if you can get the right things into the context, I've had very little problems with hallucinating when it's like you're asking a question about your code. Wrench2474 says, yo, hello. I hope you're having a good evening. I'm having a nice time this evening now. Everybody's in bed, get to work on my project, get to do some things that I've been thinking about. Now, we might have some 2D elements here too. We'll see. And I think I don't really want to rebuild this. Like, I don't want to have functions for sort of swapping the guts of this out for different planets. So I think we can kind of think about constructing one of these and throwing it away for a different planet. So I'm gonna make I think for now this will be fine. I'm gonna make no, actually I don't think I want to do that. I think I can do it just like this. So yes, so Wrench, I'm working on a 3D space combat game, and I'm working on integrating actual orbital mechanics into it right now. So we're doing some neat stuff that I've been wanting to do for a long time. Yeah, so the main thing that's going to happen here is when we swap out, like, say, a different planet or something, there's just going to be some scale factors and different things that have to be redone here. But, you know, I think we can kind of assume we're going to be looking at one planet at a time. There's going to be a set of orbits that doesn't really change. Yeah, okay, so actually, let's think about this. We can have an internal config class here. So, config, and this will be an adders class. And what are we going to have here, right? So we're going to have a body. So and then we're going to have different orbits, which we'll get from the entities. So let's see here. So this will be a celestial body, and then yeah, we'll just call this orbits. I'm not exactly sure what this is going to be yet. It'll probably be ints, because that'll be like the UIDs of the things that we're visualizing. Just for people who are tuning in, I will show you what the game looks like and what we're doing here. So just stub these things out here. Let's see, I'm gonna call this, yeah, okay, so yeah, there'll be some other things here, but so this is what the game looks like. I am working now on integrating actual orbital mechanics, so we can have space stations and things like this in orbit, and our flight control system is using the location of that orbit as a reference point, but there are actual forces that are acting on us, like like the gravity of the planet, our thrusters, and different things. And so you can see this is our sort of absolute velocity in the global coordinate space. This is our velocity that's relative to the station. And let's actually just bring ourselves in with a little time multiplier here. And, you know, our absolute velocity is, we're moving around the planet, but we're kind of in sync with the space station. I haven't updated my shadow map stuff. I'm doing kind of like a poor man's implementation of I forget the term. It's like where you have shadow maps of different resolutions. But we can fly around the flickering is because we're moving around the planet, right? And we don't have any geometry wobble because we're doing that sort of floating origin, right? And then if we look at our orbital status, yeah, see, like we have like a perfectly circular orbit. Our altitude is pretty much fixed, unchanging. So Wrench 2474 asks, are you going to make it multiplayer or keep it single? Definitely single player. So this is it's going to be a sort of a story based space combat game in the style of old games from the 90s, like Free Space, MechWarrior 2, TIE Fighter. That's kind of what I'm going for. And I have the sort of old school no texture map gradient kind of graphics. Okay, so but then what I showed earlier is if we remove the station as a reference point, so my target velocity is 0. So if I remove the station as a reference point, now my flight control system is going to try to get my velocity to be 0 relative to that absolute point, point in space where I am right now. So we're going to see the station drift away. So so there it goes. So now my drives and thrusters are engaged. You can see these things here trying to keep me there. If I drift, it should move away even faster, and you can see it. And then even if I target it, you can see, and you can see too, my velocity is there. If I stop drifting, it should sort of move away even faster as my flight control system tries to keep me in the same spot. And I think, yeah, you can see my altitude dropping and the eccentricity of my orbit increasing. What we're trying to do now is we're trying to build a 3D visualizer, and we should be able to see the orbit change as these things change. So some interesting comments here. So Wrench 2474 says, nice, I've actually never played any old school style game. So some of these old style space combat simulator games aren't necessarily for the faint of heart, but I think they're games that have held up really well and have a really cool style to them, so you should definitely check them out. And they're pretty cheap to get a hold of too. The original Free Space, I believe, is on Good Old Games, can usually be had for cheap, and there's some different efforts to keep it up and running. TIE Fighter you can easily run in DOSBox, and that's just a great game. TIE Fighter is often considered to be one of the best, if not the best, Star Wars game ever made. And so if you like Star Wars, you should definitely check out TIE Fighter. And if you're asking about my game, when is it coming to Steam? Any date planned for it? No. So this is a side project. It's just a fun hobby thing. I used to think, oh yeah, maybe I could get somewhere in a couple of years with it. I am just enjoying developing it and, you know, doing different things with it. I think there's a very good chance um, that someday it'll be available. But for now, we're just enjoying it. We're enjoying the process of making it. People seem to like me watch. People seem to like watching me develop it. Um, and there's a lot of different aspects to this project. So there's the game. There's some 3D art. I also do some stuff where I 3D print some of my ship designs that I've made for this game. So if you're interested in any of that, you should check out some of my other videos because there's a lot of different aspects to this project that I've done on stream. So Spaghetti Software says, "Man, I've made so many games I get tired trying to get other people to play them." Yeah, exactly. You know, uh, that's a whole nother project in and of itself. But I think art, you know, and I consider this to be an art project. Like it's kind of the best when you're just doing it for yourself. um, like yeah. So Spaghetti Software says, "I make them to my exact taste." Yeah, yeah. And that's a good way to put it, especially like for me, since this isn't my career, you know, game development isn't my career. It's just a nice thing, and it's a nice thing to do and enjoy, and you know, I think great art kind of comes from a sort of a deep place, and things that are made well will find an audience eventually someday. So maybe my stuff will, but uh, for now, it's a fun thing that I can do when everybody else has gone to sleep on a Friday. So, and it's fun hanging out with you guys, hearing about your projects and what you're doing. And I hope that me working on this is kind of an encouragement to people to work on their own creative projects because, um, you know, I think in our world it's very easy to get distracted and caught up in things, but I think it's very fulfilling to try to work on projects like this, even if they never end up in front of other people or whatever. So, okay, let's get back into this. So, basically, we're going to set up some different elements in here, and then the idea will be when we pass in a config, then we will update the necessary elements and scales and things so we're ready to visualize. Let's see here. So I think, yeah, we want some kind of scale here. One is absolutely ridiculous. And then, let's see here. There's going to be some scenery here, and we'll get something like the pieces for that planet here. So we'll have something like like a sphere, right? That is going to be that like a wireframe sphere. And then, let's see here. I have maybe another good example here is going to be like the targeting UI. So with the targeting UI, I've got like dictionaries for the, oh, you know what? I could actually separate that out here too. That's what I should do. So this will be the actual, yeah. I'm still getting used to this sort of new style that I'm doing things in. Okay, so this will actually just be a address class too. Yeah. Okay. And let's see here. Where's the font? Oh yeah, okay, so we might not even need font as a thing, but I think we do want scale. And then this sphere thing is going to be something for sure. And then this, instead of a class constructor, we're going to have this be a build orbits UI with our font. Okay. Yeah, so Godfather DX1 Ascent says, I didn't realize you could do game development with Python. Yeah, it's probably not the ideal choice, but I really like the Python programming language, and I found a nice engine called Panda 3D that I'm using. So it's older, but that kind of suits the style that I'm going for, and it's fun. It's actually kind of a light wrapper around C++. So Spaghetti Software has some interesting comments. He says, we're lucky. Everything we create, if we do it right, they will last forever and on a long enough time scale. I think they will find life somewhere by somebody eventually. That's a nice way to do it. Think about it. Spaghetti Software says, it's a super lightweight game engine that runs on GD script, which is basically Python with a colored hat on. I'm not sure what engine you're talking about there. Panda 3D does not run on GScript, so I'm using Panda 3D here. But okay, so here instead of having these things, we're going to just construct this stuff, and I think we still want to have these elements 2D and elements 3D. I think that's a useful thing. So we'll put these here. Let's see if we use them. Oh, Godot, yeah. Yeah, Godot, I looked into a little bit, but I didn't like the idea of having to learn a new language. My project has a lot of like overlap between the different parts, and it's nice to know I can kind of swap out parts, and I'm all in the same language, so So yeah, let's take a look at this, because we're going to use some similar components to here from the simulation for the planet. Let's see here. Oh, nice. Okay, so that's where this happens. Okay. Sim orbit. There it is. Not seeing where I'm creating this guy. Oh, let's see here. There. Okay. That's strange. Orbit moon. There it is. Oh, okay. There it is. Oh, interesting. Okay. Interesting. Okay, so let's see. Do I have a part? This might be interesting. This might be this might be what takes some time, is just getting a sphere in here. That would be disappointing. Oh, nice. So, Godfather DX1 Ascend says, "Here I am learning Python myself, but I have no functional understanding of what could be created. I'm a gamer, but I've worked EMS and law enforcement my whole life and don't know what to even create." Yes. So there's never been a better time to learn coding. And I don't say that just because of AI coding. There's so many tutorials and resources, and everything is free. And honestly, you can do anything with Python. That's what I like about Python. Is it literally is a language that you can do anything with. Really, any games. Maybe not. Maybe one of the things that Python doesn't do as well as other languages, but anything you want to build web apps. Data analysis stuff, image processing, machine learning. It really is like, it really is the best. And, absolutely, it's never too late to learn. So, okay. Let's see here. Let's actually work on, before we get too far ahead of ourselves, let's work on just loading a sphere. Let's see here. And I think I know how to do this because we just did this for the planet. We did this for the... Do I have a UV sphere that I use elsewhere? Just like a general sphere somewhere in the engine. Okay. Let's just go back to this here. So there's a miscellaneous parts here that would be a good sphere. There's the sphere. Okay, so it's in miscellaneous, and this should be plenty for what we want. So sphere part is what we want. Sphere part. It's file name. Yeah. Okay. So we want to basically do something like this. And let's see here. BT. What was BT? This is just kind of some of the plumbing here. BT. Oh, come on. Let's see. Oh shucks, that isn't it. That is the Blender side. Let's see here. default shield is going to use that sphere though. Shield test animation. Shucks, where is that? Shield. Okay, I do actually just straight up load it into this. So for now, let's just use this so we don't have to mess around too much. So so we'll just do this. Oh, nice. Okay, so Spaghetti Software is learning to code recently too. Yeah, so agents or LLMs are really good for asking questions, and I think that there's a lot of benefit to be had from them. I mean, you can get a lot of stuff done if you just tell them to write code for you, but if your goal is to learn, then they're great for asking questions too, and you can ask very specific questions. You can ask very specific questions and kind of come at things from a lot of different angles, and they're very useful for learning. Highly recommended to spend some time with ChatGPT or Gemini or whatever if you're trying to learn stuff. You know, ask questions and think, right? Now you also want to double check what you learn, because sometimes in specific areas they will just make stuff up. Gemini I found is very good at, like, if you're trying to ask questions about software, like trying to solve a particular problem, it will just make stuff up. That's probably not as big of a concern like if you're trying to learn sort of known skills or knowledge, but still something to keep in mind. All right, we've got these different things. Let's kind of wire this stuff up here. So and let's just, for now, comment this out because I don't have anything particular to use with it yet. Let's see here. So scale. That's right. Okay. Oh yeah, it's Spaghetti Software is talking about how if you had ChatGPT back in college, yeah, you know, I think of the things that I learned just by kind of beating my head against the wall. You know, at the same time, I think there would have been the risk of like just using it and not learning things, right? I think you have to be, if your goal is learning, you do have to be very intentional about how you use these tools, because they can definitely be a shortcut to just not learning anything. Okay, so let's, before we get too far ahead, let's just try adding this guy to our HUD and making sure that it is there. And let's try to get this sphere set up so that it's rendering correctly, and then we can start manipulating things. It's gonna be a little, there's probably gonna be a little bit of pain at first just to try to get things in the right spot, but I think if we can persist through that, we might have some neat stuff to see after a bit. So a lot of people watching. This is one of the biggest streams I've had in terms of people watching. I hope everybody's having a good evening, and maybe you're doing some chill programming yourself. We're not in a rush here. We're just enjoying the process. I hope your night is going well. I'm having a great evening here. Okay, so yeah, see, like, the HUD is kind of, my HUD class is kind of a mess. I'm trying to make things more modular, so right, rather than tossing all of these things into the HUD class, we are kind of building a separate thing. So let's just toss it right in here, maybe along with the velocity indicator. So I equals okay, and then we're gonna have to hook up the elements. So this is kind of the tricky part. So this is like sort of a map of like where the different things go. So we're gonna call this the let's see. Let me just read this a little bit. So these, I think, are mostly 2D locations. But I think we still do want... Let's see here. Let me think about this. Let's see here. What do I do with Elements 3D? I think I must reparent these at some point to I'm just kind of revisiting here how I'm doing this. Interesting. Elements. Okay, so that's the reparented to that. So Elements 3D. I'm just reparenting directly to base render. And then I bet I'm setting... Let's see here. Nice. So Butch Dean says, I'm currently having fun with DSAs in C++ just as a refresher. Nice. So in my day job, I do a lot of machine learning stuff with Python, but our production code base is C++. So when I integrate some machine learning model or have to fix a bug or something, there's this giant C++ code base, and I get to work without it. It's fun sometimes, also frustrating. It can be really interesting. And just an exciting channel milestone here. I just hit 300 subscribers. So thank you to everyone who's watching. Thank you to anyone who's watching who subscribed. This is fun. It feels good to hit that milestone. Thanks to everyone who helped get me there. Nice. Thanks for subscribing, Butch Dean. Are you just using C++ for fun, or do you use it for work or something outside of your DSA stuff that you're talking about? I had to write a lot of C++ in college for operating systems, and then I've used it in my work at different times for like image processing and low-level stuff. Usually I end up writing, using Python or other things. But C++ is kind of fun to get into. Some people seem to really have this kind of like visceral hatred of C++. I think like on X you kind of see that. People are like, oh, C++ is so horrible, and they either kind of like fall into a camp of like going hard after Rust or C or something. And I don't feel that way about C++. I think it's like most languages, you kind of have to choose the subset of things that you want, features that you want to use. But I think C++ can be kind of nice because it sort of gives you a range. Like you can write it like C if you want to, or you can write very, very cool high level stuff. Like our code base at work, they use lambdas and stuff like that in it a lot, and it works. It's actually quite clear and clean what's going on. You can do some really nice static analysis and stuff on C++. Oh, nice. So Butch Dean says, I'm a professional C++ programmer for over 20 years. I've worked in games dev, aviation, weather forecasting, and databases. So C++ 14 and up, basically. Nice. Yeah, I think some of the first C++ work that I did professionally was like, it was like really old-fashioned style C++. Like not even using smart pointers or anything like that. And then I forget, I think it's like C++ 17 is maybe like what we're kind of using at work now. It's kind of not my wheelhouse, but yeah, there's advantages and disadvantages to both. The smart pointer stuff, I don't know if I could really write from scratch. Seems like there's too many like ways you can shoot yourself in the foot, but like working in a code base that uses that and you're sort of following their conventions, it's nice. So okay, I'm just kind of, for people who might be joining, I'm kind of refreshing myself here in terms of how some of the 3D elements in the HUD work. And I'm trying to figure out where to attach this orbits viewer. So let's see here. Okay, so I'm just sticking that right on base render. And then, am I setting the position of that? Yeah. The elements. What is going on here, though? Okay, that's the, yeah, okay. gotta see here in GameInit when I just trying to figure out, because these elements, they have, it's like if they're in 3D, I think they're reparented to the player at some point. But I'm just trying to trace through and figure out where that is. So they have to either be reparented to base.render. Oh, actually, no, they don't have to. Yeah, they don't have to move, because all this stuff is kind of like external stuff. It's stuff that I do actually want to have be out in the game world. So I'm trying to, I'm trying to think, because see, this is an interesting thing. This is a little bit of a different case. So it's like going to be a 3D view, but it's going to be like in the cockpit. Now, one thing I could try to do here is I could try to put it in aspect 2D, because I think that's where the 3D model, like the targeting system 3D model ends up. Ultimately, I'd kind of like to get away from that, though. So, let's see. Let me just look at this once. Butch Dean says your project that you're working on here is awesome, by the way. Oh, thanks. Yeah, so like this 3D model, I think this might just be, let's see here. I think this might just be in aspect 2D. Yeah, because it's like an orthogonal projection. There's no perspective, which actually, you know, might really be what I want for this orbit sphere. Okay, let's take that tack with it here. So because I could put that in that orthogonal space, and I could tilt it or not. Yeah, I think that works. I think that works. Raz19 says, "Oh wow, that runs surprisingly smooth." Yeah, I have it limited to 30 frames per second. But yeah, I mean, there's nothing complicated about what's going on here, and this is a pretty beefy machine that I'm running right now. It's a M2 Max MacBook, so it's got some horsepower. I really want to get at least to the point where I'm seeing this sphere on the screen. So let's try this. Let's try just putting it in the 2D space. So I'm gonna swap this out here just so we're clear. And I think like in the targeting HUD, see, target model NP, this is the analogy here. So what ends up, like, how does that end up, where does that end up getting put? Yeah, see, we're just reparenting that to a thing that ends up being in the 2D, right, so target text NP, target text NP is going to be a thing that is, let's see here. Let's just trace this through once. When we build the MFDs, target text ends up reparented probably to set up, let's see, text dot np dot so these, it's going to be the, yeah, it just ends up being reparented to the MFD, and then in the HUD, the MFDs go here, and then they're gonna be I think is it other elements? Nope. These, yeah. So yeah, okay, so the analogy is going to be this, right? The internal cockpit elements. Let's see. And let's set up a space for this to go here. So MFD left, MFD right, orbit, orbits, display. Display, but orbits display is going to be self dot orbits UI dot elements 2D, and then we've got to sort of set the positions for that stuff too. External here we have to set up as well. And then let's see here. Let's see, where do we set the positions for that stuff? Okay, here we go. So external config orbits display, we're just gonna put this right smack dab in the middle of the screen. And yeah. Oh, and then this is a position and a scale. Oh yeah, both of these are positions and scales. So these are vectors, yeah. So yeah, we'll just put this right smack dab in the middle for starters, and then see where it goes from there. Now, yeah, the external scale might have to be quite a bit higher. And it actually might have to depend on, well, actually, no, it shouldn't, because the aspect 2D scale is the same. In Panda 3D, there's like two separate sort of predefined render trees. There's a 3D one, and then there's one called Aspect 2D that you can use for like doing UI elements. So that's where I'm going to put this. I'm going to put this in that sort of orthogonal UI space. Okay, and let's see if we can't get that sphere in there. And actually, I think I actually know already. Well, no, I want to just leave that at 1, and we're going to do the scale on this side. And we're going to start the scale actually at 25%, because aspect 2D is set up such that like it's 1 and -1. I'm gonna keep the sphere let the sphere have a radius of 1. So we're gonna have to size it down to fit. Okay, now let's check something else, which is we want to get that sphere set up with the right shaders and stuff, and then we can, I think we should be able to actually run this and see it there. Orbit moon. Okay, so this is going to add the wireframe. Effect. And then okay, nice. And then we're gonna need the shaders to do that shader setup. Actually, this we're gonna have to do somewhere outside, just for now. And it probably, because none of this stuff takes. There's some odd setup somewhere in here. I think we can do the wireframes here, right? But let's see here, game HUD UI dot orbits UI dot sphere np. Wireframe show through. And I think this add wireframes, I think it replaces stuff, right? Matches, add wireframes. Now how do I, there's got to be some way though that I get rid of the, I do something to get rid of the original geometry. Let's see here. GMP. Oh, I think that's what's going on here, is I'm showing through and then hiding the original. So we can stop hide and okay, now, this might be the painful part, just to see if this is actually showing. Oh, actually, this we should do a couple things with. So we should well, okay, let's just see what we get. Let's just see what we get. Yes, okay, good. There it is. That is actually almost exactly what I was hoping we would see. Wonderful. Okay, and let's see, does it persist? It persists across the different modes, which is exactly what we wanted. Okay, cool. It's bigger than I expected, but it could be that I'm misremembering exactly how the scales of these things works. Doesn't really matter. Oh, I know what's going on. I'm not actually applying that scale. This should be kind of like a reference, right? So if I say scale equals 0.25, then I should set this. This is just more like something we can query. Yeah, I don't know if we even really need this, because we can have the scale of elements. Let me just double check something. When we're building these things, do we reset the scale? Okay, I think we do actually just want to control the scale here. Because it's here, external config. If we go through this, yeah, we're setting the position, we're setting the scale here. We don't need a scale on the overall thing. We could use a scale on the sphere. Okay, that is what we want. We do want that. And we want to set the scale here. Scale. Yeah. And then when we update it, let's see, derive new scale. And we could even make this a default here. Yeah, this is what we want. Okay. And then we would update stuff here, mutate things, right? So, yeah. Okay. Yeah, that is basically exactly what I want. Okay, cool. And eventually I'll replace it with a sphere that's got like a UV sphere rather than an isosphere, but that's fine for now. Okay, so yeah, okay, so we've got the sphere. Let's try to get actual orbits in. It's late, uh, but I feel like we've got the annoying part. We've got the annoying part out of the way. So, um, okay, so given these things, we want to pass in, um, let's see, how do we want to do this? We want to pass in a set, maybe a subset of entities that we want to show, because I want this to be flexible. So this is not like a full entities, the full entities list. We'll call it entities subset. Okay, now we've got this orbit thing, and I think this is actually gonna, we'll just say this is actually gonna be a trace. So, okay. So, we've got to, oh, and we've got to, let's see here. Actually, no. No. The, these are in here. The, entities that we're tracking are going to be a set of UIDs, right? Because targeting UI, yeah, arrows, yeah. Actually, I don't even know if we need that, but it's okay. Okay. And for starters, this will just be empty dictionary, right? Because we don't know ahead of time what we're gonna have in there. Okay, so now when we update, yeah, okay. I guess this is all right. Yeah, I could actually, here's what I can do. I can actually have that config. I can have that config out here. just be empty set, and just for clarity, we can make this guy optional. Yeah, because we want to kind of understand the situation where we're not actually we don't actually have a body that we're tracking. Okay, so yeah, and then this is the subset of entities that we're going to actually no, this will actually just be let's go big or go home here. Okay. So, let me think about this a little bit. Yeah, this is what I want. Okay, because we're going to be basically using this config to update the UI. So we'll kind of communicate with the UI part via this config. Okay, so okay. We might want to use this for for some other stuff, so let's calculate it here. Vec, and then I think vvec this is going to be Yeah. This. So. Okay, so here's our orbital elements. Now, what we need to do is we need to write a little something that is going to let us sample the positions of the positions around that orbit at a given time. So we're going to do a little Googling here and see what we come up with. So let's see. Oh yeah, that's right. There's that transcendental equation. Nice. That is funny. All right. Well, yeah, it's very late. Butch Dean says he's got to drop. Have a good night. Thank you so much for coming. It was fun talking with you, and hope you have good luck with your DSA, C++ stuff that you're doing. And thanks for subscribing as well. It means a lot. Okay, so I've actually written this stuff for another project, and I'm kind of debating now whether I should consult that project or try to rewrite it. Because this is a little bit more complicated than I remember. And unfortunately, the other project, I don't have a good IDE for it. It might take me a while to bring up. I remember when I did this, I believe I just used like a couple iterations of not iterations, but like I did like a what's the term? The Taylor expansion. So I took like just the first few terms of the Taylor series. And this rotation stuff. Man, I thought there was just a nicer. I thought there was a nicer way to get this. Cause see, like with the orbital elements, basically it's these parameters that describe an ellipse that has a certain shape, and it also has a certain orientation relative to the planet. So what we're trying to do here is just, given these orbital elements, I want to find that ellipse, and I want to plot it at a given resolution. Usually, you end up with something that's sort of parameterized by time, and then there is a for like maybe, let's see, maybe I'm thinking of something else. Maybe because see, in my other project, I was actually like I was trying to get orbs over time. I don't care about time. I mean, if I could just parameterize it as degrees around the ellipse. Let's see here. Yeah, see. Create a set of points for true anomaly. Let's just have a little chat with Gemini here about this. Because I think if we parameterize by true anomaly, that avoids that that Newton iteration stuff. True anomaly, avoid the thing where you have to I like being able to ask questions. Yeah. Now, of course, this could very well be the AI stroking my ego, but yeah, you have to solve Kepler's equations when we are parameterizing by time. So if we can parameterize by true anomaly, then we don't have to do that. And yeah, and see, I don't give a care if points are bunched up. I just want a quick geometric trace of the orbit. So this is going to give me what? This is going to give me what I want. Now, it is very tempting to just copy this and paste it. But I don't want this crap. Let's see here. Yeah, because see, this is like baking in the rotation matrix. Yeah, see, yeah, this orbital plane. Okay. Let's see here. Let's take a look at this. So, let's see here. The points. I'd rather construct a yeah. I vaguely remember doing this in my other project. Okay, so I think the upshot here is this is late at night. This is going to be a lot of typing. Not a lot of fun to watch. And I want to sit and work through this rather than just copy and pasting from the AI stuff here. But basically the idea here is that what we're going to do is we're going to, you know, given these orbital elements that we can get given the current state, what we can do is we can find points around the orbit parameterized by anomaly, either eccentric or a true anomaly. Yeah, and then we want to use those construct or update a trace. So I have this functionality called traces, which I can actually show here. Whoops. So I have this functionality called traces, which there's our sphere. Nice. Let's see here. Actually, there's going to be a better example. And let us just turn off that for now. Oh, it's showing through. Let's see here. Do this. So traces, but you like see the positions of things over time, right? So it's like a sequence of points that we're drawing line segments in between. I have traces turned on for these different ships here. So we're basically going to construct a trace for each entity that we're going to visualize, and then we can use that trace to draw the ellipse. So and we'll probably do something here where, you know, if we don't already have that trace in our orbits list, then we will construct it for the first time. If it's already in there, we'll add it, and then any traces that we have that aren't in our entity list we'll toss. And then we'll have to derive a new scale, potentially based on some maximum values we can get from the orbits. I think we might actually be able to get, I think we can look at the, it's like the, in these orbital elements, I think given the eccentricity, let's see here. It's like given the eccentricity, let me just review this. Let's see here. Oh, semi-major axis. Yeah, given the eccentricity, yeah, something like the semi-major axis would let us derive kind of what the limits are, and let us do the scale factor. Actually, the apoapsis the farthest point in the orbit from the central body, right? Let's see here. So the semi-major axis. Let's see here. Apoapsis. Yeah, apoapsis is semi-major axis times 1 plus eccentricity. And the semi-major axis, it's like this conic span thing. With the lines that connect the okay. Yeah. Oh, okay. Let's see. There should be a nice diagram here. Yeah. So actually, I think the things that I'm finding here are the rotation describing elements. I might have to revisit this and look for additional things that I need to add to be able to draw this, but yeah, because we know, like, when we construct this, we should have all the information that we need to do this. So, and I found a nice website that was kind of talking about this, but there's all kinds of different there's different aspects to this stuff where, depending on what you're trying to do with this information, you might not need something like semi-major axis, apoapsis, that kind of thing. So yeah, because see, what do we have here? I have the orbital angular momentum, which might not really be something that we need. Inclination, eccentricity. Let's see here. What is that RANN? That is... right ascension. Okay. Yeah, it's right ascension of the ascending node. Yeah, okay, that's the same thing as this. That's like the angle of where the that's the angle of like where the ascending node happens, right? It's like the it's like the yaw, right? If you're thinking of it like an ellipse, it's got sort of like it's like got pitch and yaw. Inclination is kind of like the pitch of it. Yeah. Yeah. And this Euler angle thing is kind of like what that code that Gemini generated was like using to create a rotation matrix from. So basically you can parameterize this stuff by one of these anomalies, right? And then you can get the shape. So we've gone for a couple hours tonight. I think I'm gonna do some of the less fun typing out stuff offline, and then we'll come back hopefully sometime soon and see a nice UI where we can visualize some of these orbits. I'm pretty excited about this, and I think we honestly did some of the hard part tonight just in wiring up some UI stuff. So thanks to everybody who watched and hung out. It's great talking to you about your different projects, and thanks for watching. Thanks for subscribing. wish you luck and success in your creative projects, and hope you have a good weekend this weekend. Thanks again. Have a good night.